students, I am Dr. Virenderjeet Kaur from Department of Physics, Khalsa College, Patiala. Today I am going to deliver a lecture on the topic An Overview of Nuclear Phenomena. This lecture will be helpful for BSc as well as MSc students of physics. In nuclear physics, we study what is happening inside the nucleus, how protons and neutrons are arranged in the nucleus, structures of stable and unstable nuclei, isotopes, isotones, and isobars, and finally, the applications of nuclear physics. Generally, we consider the origin of nuclear physics from the Becquerel discovery of radioactivity in 1896. Radioactivity is a process by which unstable nuclei loses energy in the form of radiation and changes to the stable nuclei. So unstable nuclei, they are generally called radioactive in nature. History of nuclear physics, it is divided into three periods. The first period started in 1896 and ended in 1939. During this period, protons and neutrons of the nucleus were discovered, as well as the quantum laws governing their behavior were discovered. The second period duration was from 1947 to 1969. During this period, nuclear spectroscopy and nuclear models were studied. And finally, in the third period, quarks and gluons were studied, which are known as the fundamental particles of nuclear matter. Earlier, molecule was considered to be the smallest particle with size 10⁻⁹ meter. Then further it was discovered that molecules are made up of atoms with size 10⁻⁻10 meter. Within the atom we have positively charged nucleus with size 10⁻⁻14 meter. Within the nucleus we have protons and neutrons having size 10⁻⁻15 meter, and nucleons are further made up of leptons and quarks. Now in the figure we have shown that a crystal is made up of molecule is made up of atoms. Within the atom we have atomic nucleus, and within the nucleus we have protons and neutrons. Since neutrons are neutral, so nucleus is considered to be positively charged, and protons and neutrons, they are further made up of quarks. So basically the combination of nucleus as well as nucleons, it form the basis of the nuclear physics. Nucleons, they are the combination of the protons and the neutrons, and nucleons, they are the combination of the quarks. So nuclear physics is essential for the understanding of the structure and origin of the world in which we live. Units and dimensions in nuclear physics. The basic units in physics are length, mass, and time, and the SI system expresses these in meters, kilograms, and seconds. These units, they are used in the macroscopic world in which we live. But when we move towards the microscopic world, that is where the nuclear physics work, then these units, they are not very appropriate in nuclear physics, where the typical lengths are 10⁻⁻15 meter and the typical masses are 10⁻⁻27 kg. So in nuclear physics, the lengths are generally measured in Fermi, and 1 Fermi is equal to 10⁻⁻15 meter. Nuclear masses, they are measured in atomic mass unit, which is written as AMU, and 1 AMU is equal to 1/12 of the mass of neutral carbon atom, and it is equal to 1.6 into 10⁻⁻27 kg. In terms of energy, 1 AMU is equal to 931.502 mega electron volt. So AMU is defined as the unit in terms of which the masses of different small particles, electrons, protons, and neutrons can be expressed. Third, the nuclear energies, they are measured in electron volt. They can be measured in kilo electron volt, mega electron volt, giga electron volt, or tera electron volt, depending on the range of the energy. So 1 electron volt is the charge on 1 electron into 1 volt, and it is equal to 1.6 into 10⁻⁻19 joule. So it is defined as the energy gained by the single unit of electronic charge when accelerated through a potential difference of 1 volt. These are the different energy ranges in nuclear physics. First is the low energy range, in which the energy is less than 10 mega electron volt per nucleon. Second is intermediate energy range, where the energy lies between 10 MeV per nucleon to 2 giga electron volt per nucleon. And third is the high energy range, where the energy is greater than 2 giga electron volt per nucleon. Remember, in the low energy range, generally we study the nuclear structure. In the intermediate energy range, we study about the nuclear properties. And in the high energy range, we study about the elementary particles or quarks. Now, this is the structure of the atom. An atom is composed of positively charged protons, uncharged neutrons, and the negatively charged electrons. So an atom is the basic structure from which all the matter is made up of, and in the same manner as a brick is the basic structure from which a home is made. Although atoms are too small to be seen with our eyes, yet scientists had indirect evidences for their existence. Now, element. An element is a substance which is made up of single type of atoms. It cannot be broken into simpler components by chemical processes. Till date, there are 94 naturally occurring elements which have been discovered. Elements may be in the form of solid, liquid, or gas. Here we have shown an element carbon, where the superscript 14, it shows the mass number of carbon, and there are two subscripts. The subscript on the right hand side, that is 8, it represents the neutron number, while 6 represents the atomic number. So the total number of nucleons, that is always equal to the number of protons plus the number of neutrons. And the mass of proton is about 1836 times that of the mass of the electron. So in the figure, I have shown that about 2000 electrons, they are equivalent to 1 proton. Now here we have shown the periodic table of the element. Generally we study the periodic table in chemistry, but here we will study in view of nuclear physics. Here I have shown different colors for the different elements. The yellow boxes, they show the top 5 elements present in the human body. Green boxes, they represent the second top 5 elements present in the human body. The blue boxes, these are the trace elements which are present in very small quantity that are required by the human body. And violet boxes, these are the elements which are harmful to the human body, and they are generally radioactive in nature. So in nuclear physics, we take the different combinations of these elements, and these elements, they are used in the theoretical as well as the experimental nuclear physics. Now these are the physical properties of the protons, neutrons, and electron. Since energy and matter, they are related to each other, so atomic particle has an equivalent energy which is shown in mega electron volt. The positive and the negative charges of proton and electron, they are equal to 1.6 into 10 to the power minus 19 coulomb. Proton has positive charge, neutron is neutral, so that's why its charge is 0, while the electron is negatively charged particle. The other important property of the nucleus is the density of the nucleus, which remains constant for all the nuclei, and it is equivalent to 10 to the power 17 kilogram per meter cube. Then size of nucleus, that is 10 to the power minus 15 meter, that is equal to 1 Fermi. And then the size of the atom, that is equal to 10 to the power minus 10 meter. Now we talk